So I'll open up the Hackathon page here, and you can do an intro about what this is all about.
So thank you all for coming. This is Kamon Onuma, architect and software developer, and he runs Onuma Inc. and he has developed a lot of different platforms for integrating BIM data and making it accessible to multiple different users, not just architects or designers. And my first memory of Kamon was hearing about the Guam Naval Base relocation project, where he designed a parametric object in GDL, and it was pretty amazing. It allowed it was an air hangar, and he was able to resize the hangar based on the requirements, and then it would resize the steel members and the bolts and everything like that, and you could see all this information. And after that, I've always admired and followed Kamon, and we're lucky to have him here. Thanks, Kamon.
Thanks for having us. So we're one of the teams here at the Hackathon. This is our first Hackathon too, so we're excited to be here. We're broadcasting it out as well too, but to give you a brief overview, in fact, maybe I'll start with kind of cutting to the chase of where we are with our hack, and then I'll get into some of the details of what we're doing here. I want to just show you a glimpse. This just happened last night, or this morning, about 4 in the morning actually, from our team that's in Switzerland working on this hack as well too. We have a lot of models coming in. And this particular view is on an iPad, but we have the same data going into Revit, into Navisworks, into RESTful web services. This is actually a project for a hospital data. And for example, if we go into this room, the names and data are coming from an owner's database that says here's the information about this piece of equipment. And what we added last night, if we click on a piece of equipment, see how it's streaming right there? This is a new one. This just came in at 4 in the morning. So this is coming from another company called AECHackathon that has a database about equipment, 43,000 pieces of equipment that ID'd that I think it's a Striker mattress or a bed or something like that, and it says here's information about that. So if you continue to drill down into their system now, so this is a web service that's hitting an owner's database that says here's what we call equipment with an ID. This is our system right here, the Onuma system. That's a web-based BIM server basically that you can edit and view, and then we have an iPad app. So all of this is basically going back to the authoritative source, and then the AECHackathon data came in. They just opened up their API to us on Friday, yesterday, the day before, whatever. And last night, the other team that was working on this interface actually hit that. So that's the kind of stuff that we're working on in this hackathon, is how can we start making connections live to other sources of data. So that's one thing. It's pretty exciting because we can basically drill into any piece of equipment and say, okay, what's that? Okay, that's that piece of equipment. And then the AECHackathon database, you can see there's a little bit of lag, but it's actually literally hitting their server while we're doing this. Okay, so, and Ryan Gear is here with me from Sketchup. He'll be presenting as well as part of the team. We've been doing this for years. It's called a BIMStorm. It's kind of a workshop on the web that we have teams from around the world participating in. And we decided to bring the BIMStorm to the hackathon. Say, what happens if we bring design teams and engineers that are doing design work and start getting programmers and developers to work with that data? So that's essentially what we're focusing on this few days here. There's been prep work in the background. There's been a lot of prep work, actually, and this has been happening for 2 years. This is a milestone, I think, in the industry, because we've been working with one of the largest healthcare owners in the world. This is just one owner, the Department of Veterans Affairs and Department of Defense Military Health System, that have a ton of data that's constantly changing in PDF format. So we said, this is nuts. You have data here about your requirement for healthcare facilities, and you're communicating that with designers in PDF and Excels. Let's take all this, and even paper format. This is not an old sketch. This is last year. Somebody that actually designed the requirements for an exam room that then gets captured in a PDF. They put it in CAD and put it in there. So we said, what if we reverse this around and get that data? It's already public on the web. This is the VA's TIL site. So the VA and the DoD healthcare system combined have 210 million square feet of facilities. It's just massive. And it's hospital facilities, which means there's tons of data being pumped to this stuff, all manual data. And we said, okay, if we can get that data in a format that can be used by different stakeholders. So there's the different types of participants in this, what goes into an exam room, including the doctors and clinicians that say, here's how we need to do operations in a room or do dental procedures, and then the designers and architects that actually put BIMs together, then the owner that actually has to manage the facility during the life cycle and do work orders and things like that. All similar data, but if you do it in a manual process, it just becomes a crazy complex thing. The thing that they did have was a system called SEPS, the Space and Equipment Planning System, which is basically their rules-based database that says if we have 300 patients in this facility, you put these inputs into it and it spits out requirements. You need this many exam rooms, you need this many dental chairs, you need this many cabinets, you need this type of equipment. So it has a database about what goes into a healthcare facility. They've had that for many years, but the bad part about it is they would use this and then push a button and output a PDF file and say, here's a 1 million square foot hospital. Can you go ahead and read this PDF or this Excel file and put it into your project? So it's a lot of kind of knowledge that was trapped in here, and they asked us to guide them on how they web enable that and make it open and accessible. So that was our task from a couple of years ago, to define a roadmap. And that data is incredibly valuable, obviously, to a healthcare organization, because if they don't get the right piece of equipment in the room, it actually starts impacting how good a service they can provide. So as far as the hack goes, one thing that they asked us to do is to set it up in a way that they can build applications on top of it, but also make it easy enough for other development teams to come in and link into it, and that's why we're here. This is not officially part of our project. We finished part of our task a few months ago. We're kind of in between things right now, but we're still pushing this message out there. They asked us to present, and they're actually watching what's happening here. That's the other opportunity here. These are real owners looking at the results of what happens in the hackathon. So it's a very interesting way to kind of think outside the box and what else can we do with this. So conceptually, they hire a lot of experts to make decisions about what goes into an exam room or a hospital. They spent millions and millions of dollars every year doing this. They capture that into the SEP system. And we said, okay, it's being captured in the SEP system. It's web-based. So if you open up web services to that, then we can actually link into it so we don't just look at it as a PDF file. And 1 million square foot hospitals are then pushed out and say, what do we need in this hospital? And that gets handed off to the design teams. So what we have today is from the SEPS database, we've actually set up a RESTful web service that you can actually query and say what is a typical exam room and what type of equipment goes inside it. So from a requirement side. And then for the hack, we've actually set up a sample project where we actually have a series of projects that say, okay, we have a clinic or a hospital with these exam rooms and spaces and equipment in it. And we have design teams also working. This is what's been happening even last night, that we put this out as a requirement, and architects are actually configuring and moving things around. On the UCLA campus, we actually picked a site there. So we actually have live BIMs coming in from architectural teams are making design decisions. And while they're making those decisions and changes, all that is accessible as a RESTful web service. So you, as a programmer, a developer, can actually go in and hit that RESTful web service and say, give me a list of equipment, for example. That's what I showed you on the iPad earlier. If we're broadcasting out, here's what equipment's in here, then another group that has equipment databases like AECHackathon can link into it and say, here's the product information about that piece of equipment. Meanwhile, all of this, from a design perspective, as you're designing a hospital, it's incredibly complex, so everything is constantly changing. Okay, we changed our mind, we need more space, less more equipment, less equipment as a project progresses. So we're simulating that in this 2-day exercise, that things are changing in the background as we're feeding this data up and broadcasting it out as a web service. So that's one angle to this. And I'll show you this live in a second as well, too. So that scenario, instead of doing things manually with paper, these owners are saying, okay, what types of teams and types of consultants are there out there that can do things with our data? That's the message we gave to them. If you open up your data, then there are teams that can do things with this. So that's the SEPS database. And there's two parts to this. One part is a database about here's all the objects that we use in a hospital, and they're very simplified objects because they're not product specific yet. They're conceptually saying we need a dental chair in this room. Here's what a dental exam room looks like, and here's all the equipment in the room. So that's a default generic template. When it actually hits a specific project, they say for this project in Los Angeles, we need another boom arm in the ceiling because we do different kind of procedures. So every instance is unique. And in the SEPS database, they also have GUIDs to everything, into the default templates and also into the project specific. So if you get a 1 million square foot hospital with 2.5 million data points in it, everything has an ID that can be tracked, which means as you get moving into reporting and into BIM, we can track everything back to the original piece of data. The way that it's being done today is the architects get the requirements as an Excel or a PDF file. They go and spend months or years putting that into a BIM manually, typing in these numbers and typing in the names, and obviously it's error prone if you're manually doing that. They hand the design back to the VA, and there's no way to automatically cross-check and say, we asked for this 1 million square feet, are we getting what we asked for in the deliverable? So if we think of this in terms of data, it's a no-brainer, right? If you have data, you can check, well, here's the requirement of all these 1 million square foot spaces and 2 million data points. Do we have that do we have that boom arm in the ceiling of that room as it gets delivered back and gets constructed? Because what's happening, as we know, construction happens and things start getting, why is this room different than what we asked for? There are changes that are constantly happening because of that. So that's the exciting part for us. This team that I described, if you go, and I'll show the website in a second, there are architects and planners that are using this data to configure the layout of a building that's being landed over there on the UCLA campus, and we're actually taking the second floor of this building and making it a clinic and moving in clinic spaces into the second floor. And as they're configuring it, there's multiple teams, multiple design teams working on it, changing it. Then we're broadcasting it out as a RESTful web service that's available to the programming team, the developers. And we have, from this, we have it coming out into our system, the Onuma system, web-based application. We have Autodesk Revit linked into that system as well too. So when you open up Revit, for example, it drills all the way down back to the original database. So we're not storing the data in the model. We're storing the data outside of the model. And when you're inside the model in any of these applications, it actually can go and drill back to the original data and find it. And it's done in different ways. Some of it's offline, some of it's online, some of it's in between. But like I showed you on the iPad, it's literally live. When you click on that piece of equipment, it's not stored in the iPad. It's going back to the AECHA database, grabbing the web service and saying, here's a Stryker piece of equipment. So it's all kind of that live thing because everything is constantly shifting and changing. We said if you go back to the authoritative source, you don't have to type that data manually into anything. Basically, you go and find as much of it to the source data. Does that make sense? I'm going kind of quickly here, but to give you an overview. So I showed you the iPad. So let me show you a little bit about, this is the website, if you can jot this down, because we have all the web services links, XML files, web services, APIs. We have links to the applications. If you, at the hackathon here, if you want to get involved with this process with our team, we actually give you access to the applications as well. So send me an email and we'll give you a license to the Onuma system and to the actual files itself. And we also have public links as well too. We're trying to make it as easy as possible. If you don't have a license, that's fine. Click on this button and you'll get the web service. So the last day, basically, this happened just in the last 24 hours pretty much. We had the AECHA database on the outside here. We had these different applications that were already talking to each other with the CEPS data. Last night at 4 in the morning, the iPad that I just showed you opened up to AECHA. We're working with Sketchup. I don't know if we're going to get it done this weekend, Ryan, or not, but we've already done the first step of getting Sketchup hooked into CEPS, but we also want Sketchup to actually have the AECHA data as well. So that's the next step. We might not get that done this weekend, but it might happen next week. But we're heading there. And then in the Onuma system, if you open it up as well, too, it's the same AECHA data. So wherever it says AECHA, it's not embedded in the application. It's going back to the source in the AECHA database. And the same way with all these other things. So I don't know how many of you are familiar with BIM, but the details about BIM, I know there's a mixed kind of group here, but in Revit, for example, if you open up the attributes about that object, that chair, there are attributes that you can actually type in information about that equipment. But in this case, it's actually with web services going back to Onuma, to AECHA, to CEPS, and pulling it into the Revit interface there. Okay, so before I go live, there's one more thing. There's another project that we work with called FedIFM. This one is actually pretty, from a hacking perspective, this one's incredibly interesting as well too. It was a 2-year effort. Everything I've talked to you about up until now, it's about kind of getting the data into the project that the designers work with. FedIFM was about the entire life cycle. They wanted to, the DoD and VA wanted to look at how do we get data to move all the way from the business requirements through design and construction into operations and manage facilities. Right now it's all completely siloed, different tools that don't talk to each other, incredibly inefficient. We did a bunch of ROI studies. All of these reports are public, by the way. That's another thing that we brought to these owners. They said, we want you to work on this project, give recommendations, give roadmaps, and build prototypes. So that's great. Let's make it open to everybody. It shouldn't be locked behind a black box. So basically share it out there, because as soon as you start sharing it with the hacking community, for example, or with other owners, you're going to get new solutions out there. Don't just spend millions of dollars and lock it away. And that was a pretty significant step for us. So along the way, we said, okay, there are tools out there like Google Earth that you can put locations on a map, because they're having problems even getting dashboards of where are all of our buildings. Their systems are so badly integrated that you can't even get somebody at the executive level being able to point to a building and know that it exists. So these are millions of dollars that are being spent on facilities, and if you can't point to a building and know that it exists, it's obviously a problem. But we're getting all the way into the equipment, like I told you. If you can point to equipment and say, here's a model number, then a lot of other things can happen with that. And the other important part to this is we said there's many different stakeholders, all the way from people that are non-techie to very techie people, to BIM experts, to non-BIM experts, to patients in a hospital that want to find that room. It's all the same information. How do I find this space or this piece of equipment in a building? And if you're if you're working as an engineer and you want to repair that piece of equipment, then yes, you need to get that information. But if you're the public, if you're a patient, you don't want to know where the air handling unit's in the building. And then the other big concern for them is cybersecurity. All of these systems are starting to broadcast out what they are, and if they don't categorize and manage it, there's people obviously trying to hack in a bad way into the systems and break things, right? So imagine an X-ray machine or some kind of MRI machine that has a link to it that people from the outside can break in. So there was this whole strategy in this project of how do you layer and categorize information, how do you identify who are you and what should you get to, and then how do you broadcast out that piece of information from the source data and give it to that person at that point in time, and then lock things up that should not be accessible. So it's that whole complex data at the bottom, broadcasting out, knowing who you are, and creating a use case and saying, here's what we want to do with it, and then figuring out also how to secure it. Because the way they handle security right now, everything is locked up. So here's what happens. I've seen this as an architect. I'm working on the Pentagon, right? Let's make that, because I've actually run that scenario with them. I'm working on the Pentagon. I need to renovate a room. The engineering team in the Pentagon says, well, here's our BIM of the Pentagon, and they hand it to me on a disk or whatever. They can't send it, put it on the web, obviously, so they slap it on an email and email it to me. And that's happened on secure models all the time, and we know that's the least secure way of emailing the Pentagon. And you get the whole Pentagon instead of saying, I just want to know how much carpet I need in this room. Whereas if you break it up into services and you say, all you need to know is the square footage of this room so you can bid on the carpet in this room, then that's all they don't even need to know it's in the Pentagon for that matter. So it's a huge security hole right now, the way that facilities are managed and shared, the information being shared. And that was a big critical part, and we had cybersecurity experts in there, and we had standards about how we do all this, and all this stuff was layered into it as well. So their current systems right now, pretty much all government systems are built as a black box with the data trapped inside the system, with in-house teams inside, development teams inside the government that build applications that build these walls around their data because that's their existence, right? They need to exist because so it makes it difficult for anybody else to get to that data and say, I want to find out the room number of this building, of this room, right? So what we told them, and this is not something we invented, obviously, we're all familiar with this. We said, separate the data from the application, create a service layer, and build apps on top of it. And everybody gets access to the same data. So you don't have to transfer that data, export it, and integrate it, and do all this stuff to make sure it's in sync with other systems and have 50 different things trying to be in sync. That's crazy. That's 1995, right? We're in 2015. This is the world we live in. Mobile applications, decoupled data, accessible from anybody with open standards and open systems to be able to link to it. So that's what happened with FedIFM. And there was a series of projects that we said, don't only build this in theory, let's actually build prototypes. Let's have agile development tasks and do sprints and build things outside of the secure environment. So we said, let's build a sandbox in Amazon Web Services. So we basically have what's called the Max platform. This is max.gov, It's a very interesting, you guys should check this out. It's max.gov. It's a government site, but it has 100,000 users, and they use open standards, they use open source tools, and they build that three-tiered architecture, basically decoupled data, shared applications, shared services, building it on that platform. So we said we need to build facility applications in there, but obviously we can't get developers in there because you have to have a secure login to get there. So we need the same environment built outside in a public way. So we built this, a whole sandbox with actual sample data to build the applications. You build the applications here, then you get security review and everything, then you move them into the production environment. All these modules start moving in. So that's what we did in a series of sprints. So this is the Max platform. What I showed you earlier with the space and equipment that we have open to this hackathon is the SEPS module right here. This is live already. So we have actual live access to their SEPS data. The reason we have access to live to the SEPS data for this hackathon is it's their standards. What do we typically put in an operating room for the VA? There's nothing secure about that. It's what do you need to go into that operating room. As soon as you say that operating room is in Afghanistan for DOD, that's a secure thing that you don't want everybody to access. But how do you put this together is open. That's what we've opened up here. And we've also set up an actual project, a sample project of this clinic is now on the UCLA campus. So we have this all available for the hackathon today. So, and the decoupled data, there's a bunch of other tables here as far as their equipment and spaces, that's also accessible too. The Max platform, we are actually hitting the Max platform from here. So we have a tunnel into, basically this is all being published as a web service, this part right here. Then the FedIFM apps, this other one here, as I'm going to show you next, are the sample, or the live applications that I talked about on Amazon Web Services that were built. So there's GIS, there's BIM, all of that stuff is layered in here. So the proof of concept one, their current applications that they use in the government, it's a monster basically. It was built in the 1990s. They have a bunch of fields. It's just a huge complex interface. It's a mess really. And anytime they want to add one new pull down field in their application, guess how much it costs? Just take a wild guess. I want to add one pull down. I want to say, well, I want to do a work order and add a new pull down. They send that request to IT. How much does it cost us, the taxpayers, to add that new field? Take a guess. Just throw a number out.
$600,000.
That's close. 500,000. 500,000 in 6 months. And they need 100 new fields. Just simple stuff, right? We said, this is nuts. So we said, let's do a proof of concept that you can build a whole new application with hundreds of new fields in a few weeks with a team of 2 or 3 people. Because we had that platform, we had the Amazon Web Services sandbox, we had their requirements, we actually built them all up. We said, build web services, build it modular, but use Angular and Bootstrap and all that stuff in there, and build applications on top of that. And bring in developers that know nothing about facilities but are great at developing and programming, doing code. And give them a task to build these interfaces. And don't rebuild things over and over again. So if you have a mapping application, you can use Esri or Google Earth or whatever. And if you have an application that can see a floor plan of a building, that's a module that gets plugged in there. And some of these are actually our applications. So that module of the floor plan is something that we brought here to the hackathon as well. So you can basically plug that code into your app and you have the floor plan of the building. But they actually built this whole thing with about 100 different pull downs and about 20 different modules for work order systems and mobile applications to look on mobile devices, to be able to interact, read and write data to the system. This was done in about 4 weeks, three 2-week sprints. The development environment was open, so it's accessible. The code was open, so it's shareable, so other teams can build on top of that. And that was done a few months ago. And then we also invited Esri and other developers as well too that said, okay, we're going to hold the data inside the Mac system and we want you to take your Esri application and build on top of that. We don't want the data to go into Esri. We want it separate. So you are basically using that as a source information about the name of the building and the name of the space, and show us in your Esri interface so we can basically swap the modules. That Lego piece I was showing you, want to be able to swap modules around. Then there was another proof of concept number 2 that was about 4 weeks. There was two sprints of about 4 weeks each, 4 to 6 weeks. And they added more functionality to the whole system. It was done again. That was delivered. And now the next phase, I think what's going to happen, this is not an actual, we kind of stopped that phase of the project, but where we ended up with is they're very excited and they want to be able to go out and find other development teams that can do the same thing on the platform. So that's one reason why we're here. Okay, so let me show you some things. I kind of rambled through all this stuff pretty quickly here, but any questions? I want to show you some things that we're doing here for the hackathon now. But any questions? I ran quickly through it. Okay. All right, so if you go to the hackathon site, the AECHackathon site, and go to upcoming events, on the SoCal one, at the very bottom, there's a link to our site, I think. Yeah, there we go. So it says bonus healthcare BIMStorm AECHackathon. Steps to BIM right here. Read more. So if you click on that, we're loading everything into this site. We tried to make it as simple as possible for teams to participate. So there's several tools here. One of them, if you scroll away to the bottom, it's also linked from somewhere else, but let me just jump directly to the web services that we've set up. It says Onuma Web. There's three APIs and web services. The one I described about a list of equipment is the 1691 equipment web service. This is I think it's a SOAP web service that's coming from the max.gov platform that I talked about. The SEPS master tables are the recipes, again from Max, of what goes into a typical exam room. They have several thousand room types, a couple thousand pieces of equipment, and recipes for all kinds of different departments and things. So it's massive amounts of data, again, coming out of there. The Onuma web services, we've actually set up an actual project that we're laying out, like I said, on the campus over here, and we have multiple buildings. Actually, the other teams are doing design work with this as well. And there's RESTful web services that you can go and get. Give me a list of buildings in this project. Give me a list of spaces in this project. Give me a list of equipment in this project. Give me the floors of the building. Give me the geometries, very simple geometries, or actually give me just a plugin that I can go in and let's see, view a plan of the building, floor plan. Okay, sample floor plan. This is actually a snippet of code. It's almost like putting in a Google map. Basically, it's a piece of code that you can plug in, and it basically draws from our server and from the max.gov SEPS web services of the space types, and it builds up a floor plan. This is built on the fly from data. So these are not static files. It's not like a PDF or even a BIM file. This is built from data. So if the data changes, the plan changes. If the name of that piece of equipment changes, in fact, let me see if this works. I haven't even tried this, but this is the same room I showed you earlier on the iPad. So this is all dynamic. This is kind of the web version of it. So we have a web version. We can at any time pull it out into another application. But if I go in here and say, let's see if this works. Yeah, view additional bedroom. So if I go inside the, no, it's not linking here, sorry. Let me go and view it somewhere else. So that's the plugin. But if I go to back to the events page, so all these web services, you can basically go there, and it has very simple ways that you can actually take these pieces and plug it into your application. If you go back to the events page and I go back to, there's two tracks. We're saying there's the designers track and developers track. So the dynamic that we've developed is there's architects and engineers that are planning these buildings right now, and there's development teams that are looking at the code and actually doing stuff with it, like Atania. That's the dynamic that we're developing here. So if you go into the designers track, for example, we actually have links to all this data. We have links to the types of spaces and kind of simple assignments here. And we have a link to the actual project that I showed you earlier on the iPad. Here's the project. So in this project, on the left side, we have links where you can download files from it. So it's hitting our server, building up a floor plan, and giving you a link to saying, well, I just want an Excel file of the list of equipment. Or I want a COBE. This is a building standard, Building Smart Alliance standard from National Institute of Building Sciences, Building Smart Alliance, I'm sorry. COBE, that's a COBE of that file. Or if I want to get a SketchUp model, this is what Ryan's going to show next, I can say build me a SketchUp model or build me a Revit model of this on the fly. So the teams that are designing right now, if they move this on the web or add another piece of equipment, or if the government client said, hey, we changed the names of these equipment, we no longer call it X-ray 123, we call it X-ray B54, we'll see that data in here, and we'll see it in the BIM, and we'll see it in the SketchUp model. That's the idea. We want it to basically trickle out to all the systems, because all of this is it's a moving ship, right? They're constantly shifting their requirements, shifting their data. The designers are changing things. In fact, I noticed somebody deleted a room up there. There's a room up there, and I think for whatever reason they decided to take it out. This is actually new just now. And if I go inside these rooms now and say I want to see this room, so now it loads a single room. So it's going to the server and grabbing just that one room. So this link, the Pentagon again, right? You're required to update this room in the Pentagon. I'm not going to tell you it's in the Pentagon, but here's what you're supposed to do. That's all the information that designer might need to get a bid on this room. There's no reason to give them the whole plan of the Pentagon. That's the idea. You basically give out a part of it. And this bed that we were looking at earlier, if I look at the attributes, yeah, there we go. This is the Tania data. So this is live coming from their server, the same one that I showed you on the iPad, now inside the Onuma system. And if I upload it to Revit or to Navisworks, it'll actually have the same files there as well too. Real time. This is basically happening. This is this is our first hack last night, actually. We didn't think we were going to make it on that, so that's pretty exciting. And everything has a GUID, so we're tracking all the GUIDs of every single instance of every single piece, the type, all that stuff is in here as well too.
Then you want to point out how when the GUID changes, that original one still knows what it was, and so you can do the comparative.
Oh yeah, the GUIDs. One thing that they spend a lot of time on is as the design progresses, this is a typical design problem, right? The owner says, I want this exam room, here's a piece of equipment I want inside it. Oh, I changed my mind, here's another piece of equipment. Designer gets that requirement, they start doing their design work. I think Balfour Beatty's running for this as well too. We've had discussions actually with them about this. But so the designers are doing their work and they're changing the size of the room, they're changing the equipment in the room. The owner's requirement is a database with GUIDs in it. The designers also has the same GUID, so we can then start doing a delta comparison. Which pieces of equipment were moved or changed. It's a very simple technology task to do it, a side by side. Here's what we asked for, now what are we getting? They're doing that manually right now, and it's impossible to track. It's absolutely impossible. You can't confirm that everything that was asked for in that 1 million square foot hospital is getting put into the hospital, which is why I think a lot of the cost overruns are happening. But part of the reason is because if you can't track data, it's a huge pain point for owners, especially on hospitals that are so high value, that if you're not getting the right thing and things change, and all of a sudden, well, why is that piece of equipment in this room? Why is that installed in the ceiling? We no longer use that piece of equipment, rip it out. That happens. The day the construction's finished, they move in the room and they say, why is that up there? It was in the database, oh, it wasn't changed here. Why is it in the PDF? So this, oh, that's an old version of a PDF. All that nonsense that happens with this kind of data is happening all the time. So if we think of this in terms of data, there's a lot of interest, I think, out there with owners that do these kind of projects. How we manage that? Okay, so let's see, where were we? We're going to do a SketchUp export from here. So what happens here, and maybe I'll go to a simple version of this first. We have, back on the SEPs to BIM site that I pointed you earlier, there are free tools, utilities that you don't need an account from, and you can put in fact, let me start with the department. So this is a very simple application that says, okay, put in your email, and this pull down here is linking to this owner's database that says what goes into a dental department. Proceed. It hits their server, goes and grabs the latest list of things that are required, connects it to our server that has geometry about where those things should be located, creates a BIM file on the fly, and sends me an email to that link to be able to download stuff if I want to, or work live online, which is what's happening with these teams that Ryan's going to show as well too, that you can start working live online with that. So the sample of that would be, and I could show you another one of this too, but here's this one was generated 53 days ago. So we date stamp these things to show the expiration date. It's only fresh at that moment because the data might change. We think of buildings and data about buildings as being pretty static, but if things are changing in the background, we basically date stamp the data the day that was created. So if I want to create a fresh one, just like I did just now, if I go to my email, I'll get a fresh version of it. This is building it live with all the pieces. So it's going to their database, our server, collecting the geometry, collecting it right there, and then basically allowing me to download the file. So let's go back to here and then go to a simple one here. A single room. I don't want the whole thing, I just want a single room here. And I put in the code of the room, and click the button again, and basically you would get a couple different things. You could get the sample output again, and I could say, okay, give me a SketchUp version of that. It downloaded a SketchUp file of these two rooms, I mean an XML file of these two rooms, and let's see where it is. So it's right there. It's 56K with all that equipment. The other one that has the multiple rooms, it's about a megabyte, a bigger hospital. It's a very compact file size because we're not carrying geometry, we're just carrying tags to the equipment and their location that can then be opened up in different files. So if I go to SketchUp, and Ryan, I'll pass this off to you in a second here. Should I go ahead and do the import once and then?
Yeah, do it, and I'll come around.
Okay. So now SketchUp, let's actually go back to here for a sec. SketchUp went through, we had all of the objects that the DoD and VA use as Revit families that they created. The Corps of Engineers created these. So there's about 800 objects, boom arms and x-ray machines and everything like that of varying quality, but that's what we started with. We use those as a starting point. They have the IDs connected to their database so we know which one is which. Ryan will explain what happened with that, but basically you guys took this and converted it and built SketchUp families of it with the same IDs, with the same geometries that are now available on the 3D warehouse. So these are all the models, the same models based on the 1691 equipment in the 3D warehouse. So you can, see the chair. So you can go and grab those one by one and build these rooms, right? But a 1 million square foot hospital, or even a single room, has 50 or 30 or 40 or 50 of these pieces of equipment, and you'd have to know where to position them. It still works. You can still do that manually. But what we did is we said, okay.
Show them the link back to the database there.
Oh yeah, this is the link back to the government database. So it's always going back to the source of what do we call these things, because if they change the name of it, we want to be able to keep that up to date. So this is the database on the government website that we told them to open up and make it public. They used to distribute this by CDs up until a year ago. Every quarter we need to burn CDs, 500 CDs, and mail them around the country. A lot of money was being spent just in that process. So we said that's nuts, just put it up here, and if you click on these objects, you'll see basic information about that piece of equipment, how much electricity it needs, what's the width, depth, and height. Very, very minimal, and it's intentionally minimal because this is kind of a government saying, well, we need a boom arm in the ceiling that has a light on it. I'm not going to tell you this is made by Siemens or whatever, but I need 50 lumens in the operating room at this level. So there's a lot of data about their equipment here, and this equipment is then used in the spaces. And in SketchUp, what I mentioned earlier, so instead of manually going in and grabbing that model from the 3D warehouse and putting it in SketchUp, what we did with that XML file that I exported is we said, okay, let's go import, grab that XML file. That's right. Yeah, the one that I just saved, the 56K, import it. And what this is doing now, it's going, let's see, I can make sure I describe this correctly. It's going to the XML file that has the ID. The ID is going to the 3D warehouse, downloading that object. It's placing it in the space in the right location based on what's on the NUMA server that's tracking the government requirements. So it's the latest known layout with the latest known equipment that's going to the 3D warehouse and downloading it.
So it's coming in real time.
Yeah, it takes a while because it's actually downloading it. And the same model, if you opened it up in Revit with the same XML file that I exported from our system, if you go to Revit with our plugin, it does the exact same thing. And it does it a little bit faster because the Revit families are all local. This one's actually going to the web and going to 3D warehouse and grabbing them down.
Or it's local.
Or it's local, that's right. We're building a local version of this as well, too. So the interesting thing is that this allows a non-Revit user to edit Revit, essentially. Because I could go into SketchUp now and say, well, I want to lay it out like this. Now I want it to open up in SketchUp. Because the data is decoupled and it's maintained somewhere else, we don't have to say we have to export, we have to pull all the data out of the Revit attributes and get all the objects and get the geometries and transfer them and move them into some other applications. Basically strip the data out, have simple objects, and then it just flows back and forth between SketchUp, Revit, or NUMA right now. And we have an AECHACAD version as well, but it's a little bit older plugin, but essentially it's the same concept. So this is the, and Ryan, why don't you show some of this here, because this has the data inside the objects and things like that. Maybe you can navigate here a little bit and show. You could show the whole building later on as well too. Any questions while we switch here? Keep going? Okay.
Do you have Onuma up? Because
Yeah, I do.
Matthew just shared a file there.
Okay. Well, I haven't even shown Onuma yet, have I?
Mm.
Okay.
Let me bring that up.
Yeah, why don't you talk a little bit and
Yeah.
I'll bring it up.
Okay. Wanted to make it really easy for somebody to engage this information, just like Kimon said, making it easy for administrators to get in and have a look at their own office, their own floor, the objects that might be the equipment that they're ordering. And so you saw on the 3D warehouse, we initially started saying, well, we'll just copy everything and we'll make a copy of it up on the 3D warehouse and people can go get it and arrange it and what these templates might be like, and really kind of that same idea of taking it from paper and looking at it and transferring it. And so very quickly along the way, we recognized there was an opportunity. Actually, Kimon had already written an app back a ways that transferred spaces back and forth between Sketchup and our Onuma system. And so what a fellow named Devin and the Trimble group did is Kimon had pointed out that, hey, we already have objects pointed in this file, but we haven't actually written code to bring the objects in. Devin went ahead and did that. And so what you saw earlier with that space coming in was the objects were coming down through the web off of the server, off the 3D warehouse server. And so you're getting in real time the objects that were over in the Onuma system. And like Kimon was talking about earlier, could be over in the Revit side as well. And so what we're doing is we're, on the Sketchup side, we're keeping up with how these objects are being developed. And actually there's about 1,000 right now. I think it's 900 and something that are up on the 3D warehouse. And that will continue to grow to about 2,000. And what we're doing is we're tracking in time with the Revit developers as they make a chunk of 100 objects. We get a link to that long page that you saw, and we develop those. So ours is a very practical effort to keep in time with helping this whole system work, but in the background we're still keeping this idea of keeping everything live, everything connected, so that this fidelity of metadata can happen back and forth within this planning process, and developers and designers can take advantage of using SketchUp instead of having to worry about buying a Revit license. Oftentimes a lot of these users will only be viewing, so they can actually use just the viewing aspect of SketchUp, which is either on the web page or the free version. So to put it out there to you guys, I want to make sure that you understand that there's these tools on the SketchUp side, the Onuma side, the Revit side. So if you're playing back and forth and you're wanting to see a transfer of information throughout the design process, and I know a lot of you are here for technology, but Kimon and I are really seeing this hack as two things in parallel. Design process is happening and delivering data to what could be technology that is absorbing this information and using it in creative ways. So that's my side of it, the SketchUp side, the content side, and I can help you understand how to use it, install it, and the detail of it. Anything else you?
Let me just say a few words of this, and maybe you could jump to that. So I didn't show this earlier, but now I've logged into the Onuma system to the same project that I showed earlier that's being broadcast out as a web service, and I have login access to be able to actually edit online. So if I take this space and I move it, or I add a piece of equipment, or I change a size of a space, it actually gets updated in real time. And like if I grab this space and say I need more space, that changes the shape of it. That's going to change the SketchUp model that gets linked to this. It's going to change the Revit model. It's going to change the web services of how many square feet is this space. It's going to change the reporting that comes out of it, the cost estimating that we might do from it, things like that. That's the online kind of so the teams that we have from the outside are doing things like this, saying let's make this building work on the UCLA campus and move these rooms into position. From here, it's basically the same. The Tanya file is also in here too, so if I clicked on the objects in here, it would actually pull it up as pull it there as well too. And we have the same model in SketchUp, so when we export it to SketchUp, yeah, here it is on the UCLA campus. So nobody's actually gone through and moved these into position. This is actually automatically grabbing the spaces. This was imported actually yesterday. So you see that space that I said was missing or was taken out? This was a yesterday's export. If I do this today and spend a few minutes actually importing it in, it would look like this. And these objects actually, do you want to drive this, Ryan, or do you want me to do it? I guess I could.
Going.
Okay. So these objects, the key thing that's interesting here is that the objects themselves actually have the same data and names associated. Nobody has to type in the name of that object because it came from that source file that I was talking about earlier from the CEPS and the ONUMA side. And let's open up the one room here that we did. This one that we just imported just now. So if we go into this one,
You want to click on one of the furnitures now.
yeah,
There you go.
I'm not very
There's
good at
several layers here that's somewhat like IFC, where there's a tree and a hierarchy, so you're kind of digging down into the building, and that's why there's so many nested groups inside of this. that
Yeah,
you're
it's actually,
getting
you can
down.
see the outline. So if I go open up the outliner, this structure is based on basically like an IFC, Kobe, kind of it's a BIM structure essentially. We have a building, we have space, and we have equipment inside the space.
Who's familiar with Kobe? You guys? It's a classification system for FM that's been promoted over the last several years. It's fairly heavy, but it is one of the main ones that is being referred to right now.
Okay, so I opened up this one object here, and this name is coming from the CEPS data, name of the equipment, and other attributes that are associated with it. And we're working on getting the same thing with we want the AECHackathon data to show up here. That's our next
So that'll be
task.
the next bit there.
Yeah.
So go to the ONUMA site and look for Matthew.
Yeah, let's look at
Yeah.
that now.
So again, to make this super easy, this planning system to engage this whole process and really a design use case, I know a lot of us are on the other side of making software and hoping that it applies to use cases, and it's not very easy to get out amongst the users and come up with a use case. But just yesterday, I brought, some of you saw my son here, Matthew. He's never actually seen ONUMA. He's played with Minecraft, he's done Terraria, he's done a lot of Xbox stuff. So he's really adept on the computer, so some of that basic training is there, but he got in and started using it yesterday. Actually designed this classroom first, so later on we've got 2 projects. We're going to put people in this classroom, the different teams, locate them in here. And then I had him go through just now to this exercise of exporting from ONUMA, like Kimon talked about earlier, opening it up in Sketchup and then uploading it back up to the server. And that's the classroom, but if you go to the other one, you'll see that he was able to do it from the time that Damon asked us to come down here and present. Kimon and I sat down. There's a little bit of a lag because of the download and the upload and the server populating the objects, but we were able to round trip that with the thought that there was some editing in between, and then it goes back up to the server, and now it's available for editing up on the server or reporting. There's a lot of reporting in the background in ONUMA. Kimon didn't even touch on that, but
Which one did you want me to
cost
find?
estimating the upload test too. He should have
Might not have shared it.
it. There it is, that one.
That one?
Yeah. So it's going to look a lot like what he just brought up, something on the campus, out in the field. But essentially that was actually just done with minimal training, and now he's participated in a larger planning process for a project. So that's the neat part of having it in SketchUp. So any questions about SketchUp? You guys come over to the desk and see us, and we can get into the nitty-gritty of it as needed.
Yeah, if you guys want to participate in the team, basically, if we can find a very simple thing to do, it could be as simple as even an Excel file output saying here's a list of spaces or here's a list of square footage, and do a cost estimate, which we talked about earlier. Or if you want to hit the RESTful web service and say I want to link live, that's another one to do. If you have applications or hardware or something, or you want to look at this in 3D, 3D is being pumped out like crazy from this. We're just basically building it on the fly as we're changing requirements. So we have tons of models. On Tuesday last week, we had a webinar with several hundred people on it, and we showed them that link to go and push that button and send a request in. We had over 1,200,000 square feet of projects with this equipment submitted from the people online, which we then landed on the football field or the practice field. So there's several hundred or thousand spaces with equipment, with VA equipment sitting on that field over there from an audience that had never touched any of this. So they're generating data as designers or as owners. Imagine owners saying, well, we want to build a hospital and here's what we have. Now we want to say, what can we use to analyze this and create dashboards and create reports and do 3D and walk through these models and use it on mobile devices. All of that is possible because now we have a link into that owner's data. So if we can find some kind of connection with what you guys are doing here, it would be really exciting. And what we're doing is, this is not just this weekend project. We're going to continue this. So what's happening, if you go back to the site and look on it, and we've even updated it this morning, we're listing all the teams that have started to participate live in this. So if you go to the events page that I pointed to earlier and scroll down, this is instructions of what you do as designers, what you can do as developers. So there's specific tasks and links to the models that you can go and work with. And then down below, we have, this is the owner's database, the data services enabled by the Department of Defense and VA. They're public, so we have them there. The development teams that are hosting the server or the data, and their platform is Max. The development team that developed the software is here. And these are the teams. Here, Sketchup is here, and Trimble, Numa is us, and we're doing the BIMStorm. And all the teams, the Innova team submitted. The Innova team is a specialist at government healthcare facility planning. They actually went into the SEP system, created a real project, a sample project with real data, submitted it to the hackathon. We have it sitting on the server as a clinic. AECHA team is the data that you saw earlier. Stryker is medical equipment that they have in BIM format that we're looking at transferring it over. Design Atlantic actually designed a whole series of buildings here that's sitting on the campus with that data in it as well. Foresight Press is basically publisher. They did the Big BIM, Little BIM. Balfour Beatty has participated in the past, and we're looking at doing something here as well too, possibly. Aditas, these guys just came online this morning. They automate the design and construction all the way to fabrication of hospital facilities. They're doing configurations and things, pretty interesting things. 4D Pipeline are the ones that built that iPad AECHA link that I showed earlier. They were 4 o'clock this morning, got an email from them and say it's there. HFR actually did a design, and they also submitted a building. And SCARMAC is also working on the design with. So there's all this stuff happening. So if you work with us here, we're going to add your logo here. And this is being presented back to the VA and DoD. So there's already webinars being planned and presentations being planned because they're interested in this stuff. They're saying, what can we do with this? So we want to see some results here, and that would generate, I think, interest. Because this is an open, we're basically in a hackathon, we can try things out and then see what happens and then present them back as a real result. And all of this, we have webinars coming up. So this is basically on their site. This is on our site that we developed for them, and it links back to their data on the VA site. And if you go here on the VA site, this is actually their official site, and it has the same information and training material that we helped them prepare for this. So this is a link back to this owner's information.
One of the things that you can do with that's all generic data. I'm not sure we mentioned that. That's coming down from SEPs because it has to remain generic during the pre-specification process. Of course, you want to get in there and substitute it with something real. You saw also one Stryker in there. So if you have the wish to swap something out in there, we can show how that can cycle back through the process as well, and you can see how that changes, especially when something might happen 1,000 times in the building. And then one of the real projects that we have going on besides the one that you showed there is a real program that I just received yesterday from a group that's actually making a proposal to hope to get a grant of money. I asked them the other day if they had an idea of how much it would cost, and they said, I don't know. I said, well, what are your spaces? And they said, I don't know. So what I did is I had them put together a set of spaces on Thursday. They got it to me yesterday. This afternoon, one of the design hacks we'll do is we'll put it together and we'll start outputting from the templates that the VA provides, which are very robust, detailed templates for a lot of the same spaces that radio hospitals use. So we're going to mimic that. And then we're going to be able to show that data back to them. And they're going to be able to make some initial assumptions on what we're looking forward to. And them doing exactly what Kimon said, which is look at that room and go, oh, no, it doesn't take 2 beds in that room. It takes 1. Or, it takes 3 boom arms in that room. And so you start this conversation with the people that they intuitively know. They've been working in the hospital environment for a long, long time, and they say, I just need a room space for this activity, but they forget what's in there. But then when they see it in 3D, they either identify that it's missing or needing something, or something might be outdated. Now, we don't even sell that anymore. So we're looking forward to that real use case workflow to come back and then impact some real design, and then that real design could go and out to iPads and other databases and energy analysis and whatever water analysis that other gal's working on. So we're looking forward to all of that. So please participate if you see the opportunity.
Yeah, we think this is a milestone as far as getting, at least having access to the owner data. This is still the tip of the iceberg because there's a ton of work to be done with this now. As soon as we start showing these models to the medical planners, like Ryan said, they say, well, wait a minute, that doesn't look right. There's not enough space for whatever. You can't notice that in a list that they typically look at a list of equipment in the space and they put that out as a requirement to the design team who designs it and says and possibly resolves it or possibly doesn't. So there's a lot of this potential now that the models are visible, and the more visible we make them in different applications, different tools, the better it's going to be. So it's not just trapped in one tool. That's pretty exciting, I think, and that's the data being decoupled and broadcasting out.
To me, it's kind of like the internet being invented. There's all of this information, and they're saying, hey, we want this platform where it's what's their term for it, where it's basically open and accessible. It's sorry, I'm forgetting the word, but essentially everybody can come in and play in the same fishbowl because they want you to come in from these different vantage points and be able to take opportunity of the data. That's why it's so open and neutral. That's the word I'm looking for.
Right.
And
So we're at an hour here, and I think we should probably
Yeah,
wrap up. Yeah. So thanks for listening, and we're going to be here. If you want to participate, we'll make it as easy as possible for you to show us how you link in with what you're doing. We're interested in what you have, and maybe there's something we can provide back to your teams as well. We have a lot of people online in the rest of the world actually looking in on this and helping with it as well. Other developers and other architects and engineers. So I think there's a lot of potential here. And we're going to continue working and show you the results tomorrow. And it's going to continue after tomorrow. Tomorrow's not the end for us. It's the beginning, basically. It's just a piece in time here, and we're going to continue this work because these are real things that are happening on actual tasks that owners are trying to resolve these kind of challenges. All right, thanks to everybody online, and we'll log off for now. And this is Kimon Onuma again from Onuma Inc. and Ryan Gear from Sketchup on the BIMStorm Healthcare Hack at UCLA on June 27th. Thank you. And this was recorded.